Hello chemists, welcome to your lesson on polyatomic ions. So polyatomic ions are a new type of ion that we're going to look at today, and you should be able to make some predictions from the name what a polyatomic ion is. So we have the prefix poly. Poly, you should know, means many, just like polyunsaturated. And atomic, well, that refers to atoms. And so when we're talking about polyatomic ions, what we're talking about are ions that have more than one atom in them. And I'll give you an example. An example is a compound called cyanide. Now, cyanide is carbon and nitrogen. Carbon's a nonmetal, nitrogen's a nonmetal, and so you should know that that's going to form a covalent bond. So let's draw it out. Well, carbon we know has 4 valence electrons, and nitrogen has 5. So we know these two atoms are going to share electrons. So these two electrons are going to come into the middle and form a single bond. These guys are also going to come into the middle, as well as these guys. And what that gives us is a molecule that looks like this. Carbon, but it still has a single electron from over here, triple bond to nitrogen, which has a lone pair. So let's think about the octet rule for a sec. Nitrogen, 2, 4, 6, 8 valence electrons. Yes, satisfies the octet rule. Carbon, however, only has 2, 4, 6, 7. So it's unhappy. Carbon isn't satisfied right now. So carbon's actually going to take an electron from some type of neighboring atom. Okay? But you can't just invent electrons. Carbon adding an electron here means that this whole compound now has an extra negative charge that it didn't have before. So even though carbon and nitrogen are joined by covalent bonds, the molecule as a whole is actually an ion because it has a charge. And so if I asked you to write the ion cyanide, we would actually just write Cn negative. When we're drawing the ions for polyatomic ions, we don't need to include all of the bonds and all of the lone pairs. We just write the molecule and its charge. Now, there are many, many different polyatomic ions out there. You don't need to know all of them, but there are a list of ones that come up a lot. They're very common, and those you do need to memorize. So I'm giving you here the list of common polyatomic ions. I'm going to organize it by cations. Cations have a positive charge, and anions, which have a negative charge. So there's only one polyatomic cation that we really see in chemistry. It's called ammonium, and it's NH4 with a positive charge. So here you can see a long list of polyatomic anions, and you just need to memorize them because these are the ones that are most common and most frequently used in chemistry. Cyanide, Cn with a negative charge. Carbonate has a 2 negative charge. Hydroxide has a negative charge. Nitrate has a negative charge, phosphate has a 3 negative charge, and sulfate has a 2 negative charge. So I'm just going to show you a couple examples of ways in which you might see polyatomic ions. So one example is NaCN, and I might say, draw the ions that are part of this molecule. And you would say, well, sodium, I can predict from the periodic table, has a charge of positive 1. And cyanide, I've memorized, has a charge of negative 1, and that all makes sense because one positive charge and one negative charge balance. Another example you might see is CaCO3, calcium carbonate. calcium you can predict from the periodic table is going to make a 2 positive charge, and carbonate, you've learned or you've memorized, has a 2 negative charge. And again, this all makes sense because we've got a 2 positive and a 2 negative, those balance. So here's an example of one that's slightly more complicated. I could show you the compound MgOH2, and you would again know that magnesium forms a 2+ cation, and you'd know that by looking at the periodic table. And OH, you've memorized, has a single negative charge, so that's why there need to be 2 hydroxide ions to balance with magnesium's 2 positive charge. If I asked you to draw the ions formed in this compound, you would draw magnesium 2 positive, then you would draw OH negative, and you'd realize that those charges don't balance. And what that means is that this compound doesn't exist. Last but not least, we'll do an example with ammonium, since that's our one cation. So, NH4Br, you know that NH4 ammonium always forms a single positive cation. And you know bromine, because it has 7 valence electrons, it'll always want to gain 1, so bromine will have a negative charge. And again, you can check that you've done this right, because the total number of positive charges and the total number of negative charges need to balance.